Hi, today we're going to talk about the displacement. It's an area in the velocity versus time graph. Okay, so displacement is equal to the area under the velocity versus time graph. Okay, so how do we do that? So let's start with constant velocity case. So if we have, this is the velocity and meter per second. And let's say our velocity is equal to 1, right? So 1 meter per second. And this is my time. So then we know, given some time, let's say this time is 1 is equal to 1 second, right? So then the displacement during this time, displacement from time to 0, time is 0 equal to time is equal to 1 second. That's equal to, since it's a constant, so it's equal to the velocity that you have times the time, right? The delta t that you have, which is then 1, right? This is your velocity right there. And then times the delta t, and this is your delta t, right? So delta t, which is also 1, right? Because that's 0 and that's 1. So that's equal to 1, and the unit is going to be meter per second times second. So that's going to be in meter. Okay, so that's your displacement. But what if this displacement, this velocity is not constant? Then what do you do, right? Okay, so you see what we did is we just basically, like take a 0.1 second and then we times that, right? So this formula here basically is the area, right, underneath this here, right? So another 0.1 second, then you travel another 0.1, right? So you add them together equal to this. So this is the area under the velocity versus time, okay? So now if we have a velocity that's not constant, right? Velocity that's not constant. So let's say you have something like this, and next second you have something like that, and next second you have something like this, right? So for example, so that's t equal to 3, right? T equal to 2, t equal to 1. And let's say this time equal to, velocity equal to 1, and this velocity equal to 2, and that's velocity equal to 3, right? Okay? Right. So this is 1, 2, 3, right? So then we know the displacement that it has, right? From time is equal to 0 to 3, right? It's equal to this area here, which is 1 times 1, right? So which is 1 times 1. And then the next one is going to be 2, right? Because it's a rectangle. So 2 times 1 again, right? So plus 2 times 1, right? And then the next one is going to be 3, right? So this level here is 3, right? So this here is 3, and this here again is 1, right? So it's going to be 3 times 1, right? So that's going to be 1, 2, 3. So that's equal to 6, and it's going to be meter, right? All right. So we're going to add another case, right? So we're going to erase some of this here. Eraser, where are you? Right there, okay? So I'm going to erase this one here. Okay, so the idea is the area under V versus T is your displacement, okay? So that's the message that we are getting. So let's see now. Join again, okay? All right, so now let's change color a little bit. Let's move it to, say, black, okay? Now, what if this velocity, instead of, kind of like that, the velocity is not like this step like that, the velocity is kind of like this. Okay, and this is still velocity, and that's time. All right, and let's say we can just kind of break it down into, lots of this kind of rectangle. Okay, lots of them, right? And everyone can be treated as rectangle. Right? So during this time, we're going to call this one here, say delta T1, and call the next one is going to be delta T2, right? And keep going, right? And let's say we break it into 100, okay? Let's assume there's some sort of, there's more than here, okay? So it's 100. So last one is going to be delta T 100, right? Okay, so the displacement that it has is going to be the area again, right? So this area, the area is going to be the displacement, right? Displacement, we call that delta x, okay? And that's equal to, right? Equal to what? All this summation together, summation of all the rectangle, right? So A1 plus A2, right? Blah, 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 plus up to A100, right? So you add them all together, right? You add them all together like that. Okay, so then that's equal to, basically you will have, this velocity, let's can treat that, right? So let's say at this one here, we're gonna call this one delta T I, right? So then let's say this velocity, right? It's almost constant, okay? If you break it into pieces, I'm gonna call this one V I, right? So it's gonna be V, I'm gonna call that V1, right? Times delta T1 plus V2 times delta T2, right? Blah, 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 right? Plus VI times delta TI, right? Blah, blah, blah. And then V100 times delta T 100, right? You add them all together. So that's going to be your area. Okay. But we know this is only a triangle, right? This is a triangle here that we are assuming, right? So we are doing this. So we know the triangle formula. We can also do it this way. And we're going to make this one here. This is going to be, let's say we're going to call this one T here, okay? And then we're going to call this one here V here, right? Okay, all right? And then we're gonna do the slope, right? So we're going to do the slope here. We're going to do the slope here. Okay. So the slope, what's the slope here? Well, let's say we have we just take this one as the delta T, and this is the delta V right there, okay? So the slope A, right? I'm gonna call that slope. This is a slope, okay? It's equal to delta V versus delta T, right? Okay, so this slope here is the rise over the run, okay? So and that's equal to the slope. You can see that slope is your acceleration, okay? That is your acceleration. So you can see then delta V is equal to A delta T, right? So that's your slope, right? Okay. Okay, all right. So anyway, let's get back to what we're trying to do, right? So the area here is equal to T times V, right? So base times height, right? And then times half. So that's going to be, this. And then what's T and then V divided by 2? So V divided by 2 is the average velocity, right? So the average velocity right there, V divided by 2, okay? So basically the area is equal to the average velocity, right? And then average velocity, well, I shouldn't say that, there's no dot there, average velocity, right, times T, okay? So that is your formula for the displacement, and that's your delta x also, right? So the delta x is equal to average velocity times T, okay? And that is the area. Okay, we're gonna stop there. Hopefully you get a little bit of understanding. Okay? Until next time, bye now.